This motor is the Franklin 3/4 horsepower motor found in the earliest greenies. Very heavy, has a nut on the end of the spring. Most of the greenies use this motor, the 3/4 horsepower GE. Also A.O. Smith had a virtually identical motor to this used. The motor most often found in headstocks is this 1/8 horsepower GE or a A.O. Smith equivalent. From time to time you might find a 220 volt motor. They're not too different from the 110 volt versions. And then the later models have this Emerson motor. These started to appear in the 90s, so they've been used for more than a decade at this point. Now if you find that your motor won't start, and what I mean by that is that you hear no humming, the breaker doesn't break, just the motor just does nothing, you need to start with the absolute basics. Make sure you're plugged in. Make sure that the outlet does work by plugging something else into it and making sure that that works so that you know power is to the outlet. And then start from your cord. Make sure the cord is good by testing it electrically. You can test the switch then to make sure the power is getting through the switch. And then finally you can take the headstock apart, take the motor out, and you can test the motor itself by going direct to the leads to see if you have any action that way. You can use an inexpensive multimeter or ohm meter to do a lot of tests for you. You can test the motor itself and see if you have conductivity between the plug and the individual wires. You can also test for bad switches, making sure there's no contact when it's off, making sure it does connect through when it's open. If you're using all 4 leads, you have to test both sides. This type of switch is the most common. This is the newer style safety switch. Some of them have just 2 contacts, some have 4. Some of these were a little bit loose and could swing and touch each other, which is one reason I recommend for the wiring conversion that we'll be showing you. Or you can replace these switches. You can find a pretty good substitute at home centers. They use a screw type of connector. The switches you get from Shopsmith for 5 times the money have these slip-on type connectors like this. You can also use this multimeter to do various tests of your wiring condition inside the motor and to test the capacitor with. There might be a possibility that some of your contacts are corroded, especially in the start relay. This particular one had a sealed start relay, as well as this type here. But most of the start relays were open, like the points in an automobile, and you can clean those up with a small needle file or with some emery cloth. And for a lot of the electrical contact work, you could try using an electrical grade cleaner, like this here I have. That can help keep the corrosion down on some of your electrical contacts. But there's not many. There's just the contact in the switch itself and then the contact within this start relay. If you happen to have a bad capacitor, and I feel that that's quite a rare thing, you can get the numbers right off of the capacitor so that you know what rating to get. The easiest would be just to take the capacitor off, take it down to a motor shop or electric shop and have them test to be sure that the capacitor is bad. I've only found one bad capacitor out of more than 50 motors that I've worked on. Now if your motor hums but doesn't turn, you could take the belt off of the sheave to make sure that the belt is not bound above. Then you can turn the shaft by hand to get a feel for whether bearings are seized up or that there's some other interference inside. Your shiv could be jammed against this housing, causing friction. So first, make sure it's not the belt. Make sure it's not something physical impeding it. If it's the bearings, which is often the case after the motor's 25 years old or so, you'll have to change the bearings. If it's the shiv binding, you can just remove the shiv, clean everything up, replace the spacer if it's too small, put the shiv back on. If the motor is very noisy, again, it could be just the condition of the bearings. As they get rough, they get noisier. It could be the shiv is rubbing on the housing. If the spacer has worn too narrow, or possibly not even in place, the shiv can go back too far and be rubbing on this housing. That alone can cause a lot of noise. So you could take the shivs off, inspect for that, clean everything up, test it again. Sometimes people tell me about sparking and what can cause sparking. It could be, again, the shiv rubbing on the housing, causing some sparking. If the windings inside are shorting against themselves, that will cause sparking. You can tell that by a burning smell or a hot odor. By opening up the motor, you'll be able to tell if the windings were shorting against each other. Everything can look charred in there. The coating should be kind of a caramel color on the copper wires. If it's darker brown or black, that shows that there was some shorting inside. If your shiv seems to run in an unbalanced manner, if you're hearing a thump, 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 thump type of sound, it may be the condition of the belt itself. If it's sat in one position for too long, it gets distorted, and it may never get back to a nice round shape after that. You might need to replace the belt. Or I've seen shivs that have debris stuck to them. And again, sometimes that happens just from the belt being in that position for years and the moisture interacting with the aluminum and causing a corrosion. You need to scrape that off, sand it down, rub it off, and that'll give you a nice smooth shiv, again, like this one looks. And that allows for good movement too. It gets rid of that thump thump vibration. You also want to inspect your shivs for any breaks. If you find any of these fins broken off of the fan shiv, any other cracks in it, that can cause an unbalance. The bearings can cause an imbalance also. So those will be things to inspect as well when you've taken your motor apart. If the shiv seems stuck, that is, you can't do this with it, you'll need to take it off, scrub down the shaft, inspect the key, make sure there's no burrs on the key. You can clean the shaft hole on both parts of your shiv and re-lubricate everything, put it back together. But you should be able to move the shiv like this by hand, and then it'll move properly for the machine as well. If your motor kicks on and off, whether it's under operation or just by itself, it's very likely to be bearings. If it's within your Mark V headstock still, I would suspect your bearings in the headstock and or your belts, and possibly the bearings inside the motor itself, and that causes the kicking on and off, under load or not. People ask sometimes if a motor can be converted from 110 to 220 volt. If it can, it'll be mentioned here on the information label. It'll show both voltages, and if that's the case, then underneath the cover you would find different posts for the designated for that. On the label, it would show you which post you use for 110 and which post for 220. I've only seen one motor out of maybe 150 Shopsmith motors that had dual voltage available, and that was from a 1962 A.O. Smith 1/8 horsepower motor. Another frequently asked question is, can we use other motors to replace the motor with? The Shopsmith, since it has that floating sheave, requires a very long shaft. Most motors come with a shaft that's less than half as long because they just use a regular fixed pulley. So that prevents you from just grabbing any old motor and putting it in here. You need this special long shaft if you're going to keep using the floating sheave technology. Is my motor reversible? I have not seen any motors which came out of a Shopsmith Mark V that was reversible. That is constructed into it by the method of the windings. Can I use a larger horsepower motor? This is answered by the question about the shaft length. Many larger horsepower motors just don't have the proper shaft configuration, and you'd have to change your pulleys. DC motors with electronic speed control can definitely be done, but it's very difficult to do within the confines of the headstock configuration. If you keep the floating sheave technology, you can make it work. It's important to check the condition of your wiring around your motor, both outside the motor and then the pigtails that go down inside the motor. If you find any cracked areas, exposed areas, you can replace the wire completely, or you could cover that area with shrink tubing, which is available everywhere. Shrink tubing can be shrunk with heat, whether it's an open flame or a heat gun, like a hairdryer or something. You might use just regular electrical tape. It comes in different colors if you want to keep the color code of the leads. And in some places it's real hard to get to. You can use a paint-on electrical coating. This is made by 3M Scotch Coat electrical coating. Sometimes that's good where the break can't be taken care of with either of these others. You also want to inspect the condition of your electrical cord that runs to the motor and to your headstock. If you don't have the 3-prong type of cord, I would replace the entire cord with this type. Of course, only if you have the 3-prong outlets in your shop, but this will make you a lot safer. Many shops are in moist, damp conditions, and by having your motor grounded and your equipment grounded, you're going to be much safer. So you can buy replacement cords like this at home centers or from Shopsmith. The home center ones you'll need to modify slightly because it's going to need little in terminals to fit your switch. If the cord itself seems good, you could always replace just the plug itself with one of these 3-prong adapters here. But in either case, make sure you're grounded right to the motor case. You can put it right under one of your motor bolts, and that way you know the motor is grounded and your complete machine is grounded at the same time. The leads on the switch are very close to each other. If they swing together at all, it's possible that they could short out. So there's a simple switch that you can do to make it much safer, and it actually brings it into alignment with the newer techniques. And that is to only use the positive leads connected to the switch and shorten the 2 negative leads and have them quick connected to each other. So it's a pretty easy change. Just need to buy a male and female insulated terminal, quick release terminal like this. And all we have to do is shorten the wire coming off the motor. Strip it back a little. Like that. Put it in here. Crimp it onto the wire. Okay, so that's on good. Now similarly, just shorten the white wire in the motor pan. Strip it. Put the other end. Terminal on. Okay, so now the negatives will be able to connect and disconnect quickly, and we'll only have the black leads coming up to the switch. So there's much less chance for shorting out in that position. And if you want to go another step further, you could replace one of these with an insulated quick connect also, so that there's no way that those two could short, but it's much less likely for a short to happen there. So that makes it much safer. Okay, so here I've gone ahead and replaced one of the black leads with that insulated type, so there's just no way you could touch this other lead over here. So much safer. Still a quick disconnect if you ever need to take it off. So that is ready to go. And also be sure you always ground your motors, so if your cord is not a 3-line type, go ahead and replace it so you're safe, as long as you have grounded type receptacles. And you can connect the ground either to a dedicated ground screw like this, or you can back out one of the regular case screws a little bit and ground right to the motor case. That's safer if you're in a moist environment in your shop. It's safe in case some of your wires inside are cracked or frayed. Just makes it much safer for you and anyone else that might use your machine. So always ground your motor, and since the motor is attached to your headstock inside, it grounds your entire headstock, makes it much safer against moisture and other shorts.